differentiation of product function. We want to see how we can differentiate functions of products. Now, look at this question here. I mean, this theory here. We have y as a function of product of two pieces. This is a function of x. Is a function. We have two functions here, and they are products. So to differentiate them, we must use this formula that dy dx is equal to u dv dx plus v du dx. That's the formula that we call product function rule. Now, or product function formula. Now, if we have a question of this nature, y equals to 2x into 3x squared plus 4. This is a function. This is a function. Now, we assign our u as 2x and our v as 3x squared plus 4. Now, differentiating the u with respect to x, we have 2 here. Differentiating v with respect to x, we have the v dx as 6x. Automatically, we can put these values into the formula, and we have dy dx now. Dy dx to be equal to u dv dx, that's 2x times dv dx is 6x, then plus v, which is 3x squared plus 4 times du dx, which is 2. Now, expanding that, we have 2 times 6, that's 12x squared plus 2 times this one, that's 6x squared plus 8. So finally we have 18x squared plus 8. So that is the derivative of this function, 18x squared plus 8. Alternatively, we can just expand it. If we don't want to use product rule, we just expand the functions and then use power function rule to differentiate. That you can write y as 2x times that's 6x cubed plus 2x times that's plus 8x. Now, from power function rule, we have dy dx to be 3 times 6, that's 18, x power 3 minus 1, which is 8x raised to power 1 minus 1, and that's 18x squared, 18x squared minus 8. So that's the derivative of that function. Now, we can move further to another example, example 2. We are considering example 2 now under the same product function rule. If our y is equal to x sine x. Now, this is a function and this is a function. If it is not a constant, it is a function. So we know that our u here is x and our v is sine x. Now from there, the u dx is going to be 1, and the v dx, derivative of sine x is cos x. Automatically, our dy dx will be u dv dx, that's x cos x, because cos, this is the v dx, and this is our u, then plus v, which is sine x, du dx. But du dx is 1 times 1. So we have x cos x plus sine x. So derivative of x sine x is x cos x plus sine x. Finally, for today, we look at another, the last example, example 3. Now we have y is equal to 3x log 5x squared to base e. Now we have our u now to be 3x. This is a function, and this is also another function. Then that means v is log 5x squared to base e. We'll differentiate u with respect to x, we have 3. We'll differentiate v with respect to x, we have this is 10x over 5x squared, and that gives us what? That gives us 2 over x. So our dv dx now, I advise that you go back to our videos and study the derivative of logarithmic function, because we treat that explicitly. Now the y dx now, the y dx will be u dv dx. Our u is 3x, dv dx is 2 over x, then plus v. Our v is log 5x squared to base e, then du dx, which is 3 times 3. This is a constant, can only become a coefficient here. So we have X cancel X, that is 6 plus 3 log 5x squared to base E. So that is the derivative of this function. Thank you very much. We wish you all the best.